All right, today we're going to look over how you solve percent error problems. What you're going to need is a calculator. You don't have to have a scientific calculator, but it will come in beneficial at certain points throughout the year. So uh, we'll say for now you don't need anything special. So our percent error, we need to have the formula written down. If you have taken my suggestion and started a formula sheet, you're going to know that anything that's dealing with percent error, you have your measurement minus the actual divided by the actual times 100. That's going to give you your percent error. All right, now here's the thing. In the textbook, I know it says experimental minus literature divided by literature times 100, and you have to take the absolute value of your answer. But you're going to see why I personally leave that percent error on there. Okay, so looking at this, we have John uses his thermometer and finds the boiling point of ethyl alcohol to be 75 degrees. Now that is his measurement. He measures that. So that's the your part. We look in the reference book and find the actual value to be 78 degrees. So if it's 78 degrees Celsius, that's the actual value. So we're going to plug these in. You have 75 degrees Celsius, write your units down. Minus 78 degrees Celsius, write the unit down, divided by. We have 78 degrees Celsius. We go times 100, and then we're going to put in the calculator what we've got. We have 75. Let's do that again. 75 minus 78 equals. We go divided by 78, and sure enough, if we multiply that by 100, we're going to get our percent of a negative 3.8, and then we'll just leave it as that right now. Why? Because there's two significant digits. There's 1, 2, and we're going to see that in the next lesson. But we have two significant digits, and why do I like to leave the negative on there? Because I know that John came up with a value less than what the actual was. So we have one problem done already. We go to 2. Anna weighed an object on her balance and recorded the mass to be, this is her measurement, yours. Her teacher told her that there was obviously something wrong with her balance because it was giving her a reading which was too high, 33.2% too high to be exact. It says, what is the actual mass? Now, we have to do a little bit of algebra for this. And this is where, if you're using the help video right here, I'm going to go through the steps on how we rearrange this formula. We're going to have yours minus actual divided by actual. Now I'm going to do away with the times 100 for right now, equals the error. Now, we have to rearrange this because what we're trying to solve for is what the actual value is. So we're going to try to get the actual values out of a division problem. So we're going to multiply both sides by a. So we go yours minus actual. You have actual times error. Then we're going to add the actual to both sides. Okay. So you have this right now. We didn't create a new formula. We just rearranged this. All right. Now, when you have this, we would like to get rid of all of the extra A's. We only want one actual. How do we do that? Well, we can use a distributive property. We go yours equals, and then if we go A, and we put our parentheses down, we go E. See if we distribute the A inside of that, isn't it AE? And we end up with these two things. Oops, let's try that again. These two things equaling what's above. All right, I will continue that process. We go plus 1. Well, if we take the A times 1, doesn't that get you just the A? Yeah, it does. Okay, so a little bit of algebra can really help you out here. Now, we are trying to solve for the actual, so we need the actual back on the side by itself, so we got to get rid of the E plus 100. All right, so I'm going to clean this up, and we're going to move that over. So we'll divide both sides by E plus 100, or plus 1, I'm sorry, not 100. That gets rid of this on this side, and now you have your actual. All right. Now, what I would really recommend is that you write this down in your formula so that way you don't have to redo this each time. I said that I would get rid of the 100 times 100, and that's where this is just one of those things you're just going to have to write down and remember. We're going to change that percent to decimal. All right, let's plug our numbers in now. We know that the percent was 33.2% too high. So what value is that going to be? Is that going to be a positive or is that going to be a negative? If it's above, that's positive, and that's why I don't want to get rid of why I do want to get rid of the absolute values. So we have 24.2 grams, that's yours, and then this was our percent. So we're going to have that percent in the decimal format, right? So that's the decimal format, plus 1, and that's going to equal our actual. So let's see if that actually comes out. You go 24.2 divided by 1.332, and it comes out to be 18, and we'll round this off, 18.12 degrees. I'm sorry, 18.2 degrees Celsius. All right, so that matches up with what the given answer is, so we did it right. Number 3, we have his book report is under by 4.5%. So we're going to be underneath what the actual should be. And it says he determined the boiling point to be 45 degrees Celsius. So this is the your part right here. It says what is the actual or correct boiling point? So that's what we're trying to find. Okay. So in our formula, we're trying to find the actual. So let's use the formula from right above. We take your measurement, 45 degrees Celsius. We'll divide it by our percent error. Now the percent error is this number right here in the decimal format. So I'll move my decimal to the left 2 places. So we're going to have 0, and that is point. Okay, yeah. I had to make sure I got my number right. We have 0.045 plus 1. That's going to get me my actual number. So we'll plug this in. We'll go 45 divided by, and I'm going to go parentheses, go negative 0.045 plus 1, close it up, and I get 47.1 degrees Celsius, and that matches up with my number. But notice here that his number was under what the actual was. So that's why we keep the negative on there. We go to number 4. Number 4, we have to figure out our percent error. So it says the density of water at 4 degrees is known to be 1 gram per milliliter. Kim experimentally found the density to be 1.085 grams per milliliter. All right. So if this is her measurement, then that means that this is the actual density of the water, and we're trying to figure out the percent. So we're going to go your measurement, 1.085 grams per milliliter. minus the 1.00 grams per milliliter. Go divided by 1.00 grams per milliliter times 100. Let's see if we come up with the right answer. Clear it out. We go 1.085 minus 1 divided by 1 times 100 equals, we have a value of an 8.5% off. So it makes sense because what was her number? Bigger than the actual. So that means that this value would be positive. We have number 5. Number 5, the Handbook of Chemistry and Physics lists the density of a certain liquid to be, so we know that this has to be like an actual. Fred experimentally finds this liquid to have a density of this, so that's the your. The teacher allows up to a plus or minus 0.5% error to make an A on the lab. Did Fred make an A? So we need to figure out what his error is here. So we go yours, 0.7914 grams per milliliter minus the actual, 0.7988 grams per milliliter, divided by the actual, times 100. All right, now if we put this in to the calculator, 0.7914 minus 0.7988 equals, divided by 0.7988 equals, has a value, a percent, that is going to be, I didn't multiply it by 100, times 100, 9.92 percent off. Let's round that because see the 6 rounds to 2 up, so that will be a 3% off. And since it comes up to be a negative, I know that he measured under it. So if the teacher's only allowing a 0.5% and he's got a 0.93%, no, he didn't get an A. We have number 6. An object has a mass of 35 grams, so this is the actual value. Huey weighs it to be 34, so that's the your. So we'll go 34.92 grams minus the actual mass on this object divided by the actual mass of the object times 100. Okay, it's going to give our percent error. Calculator time. 34.2. 34.992. We'll go minus 34.92. Whoop. I got more. See, this is why we want to write our numbers down. The actual mass is 35, so we're going to go divided by 35, or minus 35, divided by, we'll do this. Let's go equals, and we'll go divided by 35 times 100. There we go. If we multiply that by our 100, we come up with negative 0.2. Let's go to 3. So we're not going to split hairs over this. The answer says 0.22, but really when we round that off to the second place passed, we should have the other on there. Okay. We'll go to Florence. Florence measured the volume of a cylinder and determined it to be, okay, so this is the your part right here. The teacher told her that she was 4.65% off, so that's percent. What's the actual volume of it? All right, this is where we have to go back to that rearranged formula. We'll take 54.5 cubic centimeters divided by the decimal value of the percent. So we move the decimal to the left 2 spots, plus 100, and that's going to, or plus 1, and that's going to give us our actual value. So calculator time, we're going to go 54.5 divided by 0.0465 plus 1. Notice I put that in parentheses. We come up with a value of 52.1 cubic centimeters. So we did it right. Barium, chemistry. Barium gets a paper back in lab, and he's off by this percent. Okay. He had found the mass of an object to be, so this is the your. What should the mass of the object have been? All right, so we got to find that actual again. So we're going to take our same formula we'd used before. That's the your measurement divided by the percent error. Again, move that decimal to the left 2 places. 0.0277. Make sure you leave that negative on there. Plus 1. All right, calculator time. We have 100.3 divided by, put it in parentheses, we'll go negative 0.0277 plus 1, and you end up with an actual value of 103.2, and that's going to be close enough. We have one last one, and then you're done. We have, after lab, all of Henry's friends looked at his data and laughed and laughed. They told him that he was 31.2% too low. So we know that this guy, it said too low. So that means that this has to be a negative percent, right? Okay. So too low in the boiling point he had just recorded. He had recorded a value of 50 degrees Celsius. What's the actual boiling point? So we'll have your value. That's the 50 degrees that Henry had figured out. We take his percent, move the decimal to the left 2 places. All right, but since he was too low, we got to put the negative on there. Plus 1 equals your actual. So let's see if we come up with the right thing. We have 50 divided by parentheses negative 0.312 plus 1, and you come up with a value of 72.67, or we'll just say 7. And what were we looking? Oh, degrees Celsius. And there we go. What you need to do is have all of the work that I just put down on this paper. If you want full credit, I've gone through and I've showed you everything that you need to have. You need to model that same behavior of putting down all of your work, all of the units, and showing how you come up with the answers. All right, the process is every bit, if not more important, than the end product. Okay? If you have questions, make sure you ask.